welcome to Deribus Code Tech. And today we are going to see the problem in Geek for Geek is populate in order successor for all nodes. So this problem, they have given a binary tree and we need to complete the function to populate the next pointer for all nodes. And the next pointer for every node should point to the in order successor of the node. So what does it mean? See, you have an in order traversal, we need to do in-order traversal, and they also given an binary tree. So binary tree is going to look like this. Okay. So what is in-order traversal? First of all, you need to check which is the root node. So here 10 is the root node. Okay. We don't have, okay, there is no problem. Now, so we need to find out the root node's left subtree. Which is the root node's left subtree? This is 8, 3, and these are all called left subtree. And root node's right subtree is 12, and which are present in the right side of the root node, or everything is in right subtree. Okay, there is no problem in that. Now, in order traversal is nothing but first we traverse all the left node, then we'll move on to the root node, and we will move on to the right subtree. So that's we call it as in order traversal. Here, the in order traversal of this tree will be something like first we'll move on to the left node. So first we'll come to up to will come to here, okay, up to 3. So after you move on to the left side of the 3, you'll get what? Null. So we are not going to do anything. So for the condition, we are not going to add anything in our part. Okay. So first we'll get 3, then we will get what? 8, then we will get null. So we are not going to add anything. So just to leave it. Then what we'll get? We will get what? 10. Now we'll move on to here. From here, we'll see for the left node. If there is anything present in left, no, only we have 12. So we will write it as 12. Then we will check for the right node. Whether in right side of 12 anything is present? No, nothing is present. Then the inner traversal of this problem is 3, 8, 10, 12. Okay, there is no problem in that. But what the questions they have asked is that we need to traverse in this order. So if we have find out 3, then 3 points to 8. Then they ask us to print something like next 8 is going to points to 10. Then what they said, 10 is going to points to 12. Then what they said, if 10 is going to points to 12, 12 is what going to point to next? 12 is going to point to -1. So we need to return like this. We need to print like this. And most importantly, we should not return anything. Okay, we should not return anything. So just they said return and void. Okay, we're not going to return anything. So that's what the return type is void. Okay, now how we can process our this in our program. So first of all, what I'm going to do is that I'm going to check whether my root is null or not. So for the case, I'm going to check if root is equal to null. What I'm going to do is that I'm going to return it as empty. I'm not going to return anything. You should not put anything here as null. If you put return null, then you'll get something like invalid data type. Okay. Here the return type is void, so that I did not return anything. Just you put return enough. So after this, if my root is not null, so you can see first the root will be 10. If my root is not null, in that case I need to do in-order traversal. So for that case, I'm going to use in-order root. So this is a function. So for that case, I'm going to create a method, or you can call it as function. So this method is also going to return void. And what I'm going to do, I'm going to use in order of node root. Okay. Now my root will be this. Now I'm going to do in-order traversal. So in-order traversal is something that you need to move on to the left subtree. So for that case, here also I need to check whether my root is null or not. If my root is null, what I need to do? I'm going to return nothing. Just like that I'll return. If my root is not null, I need to do what? I need to do inner traversal. I need to move on to the left subtree. So for that case, in order of root dot left. What is root dot left? This is the root, and root of left is 8. So now 8 will be passed to here. 8 will be passed to here. Now the root is what? 8. Okay, I'm going to check whether the root is null or not. No, it's not null. Then check the element which is present in the left side of 8. What is the left side of 8? We have 3. Okay, now 3. Here the root or left will have 3, and this 3 will be passed to here. Here the 3 will be the root node. Okay, now I'm going to check whether 3 is null. No, it's not null. Then check the left side of 3. Okay, let me move on to the left side of tree. So now left side of tree is what? Null. So it's going to be null. Okay, here the root is what? Null. If my root is null, then return nothing. Then return nothing. Then what will be stored in the root? Currently the root will be what? 3. Okay, so currently my root will be 3. If the root is null, it's not going to return anything. Then what will be the process? It will be still in this particular process, still in the third node. Okay. Now what I'm going to do? I'm going to declare another variable to keep track of these elements. 3 to 8, 8 to 10. For tracking these elements, I'm going to use another variable node p equal to null. Okay, let me keep it as p, or you can keep it as you can understand this like as a previous. Okay, for previous element tracking, I'm going to use this variable node p equal to null. Now what I'm going to do is that, so let me keep like this. So I'm not going to do anything, and I'm going to check if my p is not equal to null. I'm going to do some operation here. Okay. Now my p is null. If my p is equal to null, then what I need to do? I need to store the value of root in my p. Okay. Now what will be stored in p? Let me make here. Initially it will be like 3. Okay. And it will be waiting for to the next element, pointing to be, it will be try to wait for the next element. So what will be the next element? It keeps on waiting. Okay, so now it will be stored like this 3, and I'm waiting for the next element. So how you can see the cursor is here, it means that I'm going to wait for the next element. Okay, that's it. Now what I'm going to do, so I came to here, and next I'm going to check for the right side of my 3. So right side of 3 is also what? Null. For that case, I need to check it whether anything is present in my right side or not. For that case, what I'm going to do is that in order of root dot right. Okay. In order of root dot right. Now in my right side I have null. Okay. Then the null will be passed to here. So if my root is null, then return empty. Won't return anything. Then what will happen? It will move on to this part. Okay, now it will move on to this part, and going to check if my p is, now it will be here. Okay, so we have already traversed our left part, but we need to traverse our root and right part. So now our root will be what? 8. Okay, we have traversed everything here. Now we are moving back to our we are moving back. Okay, for the case, now our root will be what? 8. So this will be 8. Okay, so this is not going to 8, but the value will be something like here. Okay, let me keep like this 8. Now what I'm going to do, if my p is not equal to null, no, my p is not equal to null. Reason is that I have already stored 3 in my p. In this case, what I'm going to do, in my p dot next, what is how I'm using p dot next? You can see here the class node has data left, right, next, and everything. So we can also access the next address. So for that case, I'm going to use p dot next. I'm going to store what? Root. So what is my root? 8 is my root. So that will be stored in my p dot next. Now what will happen? 3 of 3 after first initially I have 3 and then now I have stored in my next address 8. So that will be stored here. Okay, that's it. Now after this, what I'm going to do, the root will be going to store it my P. So the same thing will be happen here. So just like that, we are going to correct 3 points to 8. So that's what going to happen here. Okay. After this, what I'm going to do, I'm going to check for my right side of the 8. So in my right side of the 8 subtree, so 8, I will have what? Null. So if it was null, I'm going to return empty. I'm not going to return anything. So that's what going to happen here. So after this, it will move on to 10 and it will check for whether the 10 is empty or not. So same thing will be happen in my every iteration. So every recursive part, it try to store like this. 3 is going to point to 8, and after this 8 is going to point to 10, and after this 10 is going to point to 12. So same thing will be happen here. Okay. So for that case, let me open this code also. Then only you can able to understand. You can see here. So this is what our load is going to print. Okay, if my ptr is not equal to null, so after returning our answer, it is going to iterate up to the ptr is going to null or not. So if my ptr is not going to null, then I'm going to print all my data here in this order. So that's why they have been printed like this. 3 of 8 and the 8 is going to next point to 10. So for that case only they are going to print like this. Okay, let me minimize this. So after this, what I'm going to do, I'm going to return. I'm going to return void. Okay, no, it's not return anything. So just like that, I can put in order of root. I'm not going to return something. Okay, so we should not put return in order of root. Reason is that it's a data type of void. Okay, let me remove this and let me compile and see whether the output is right or wrong. Yes, we got the right output 3 of 8, 8 of 10, then 10 of 12, and 12 of minus 1. What is that minus 1 means? It 12 is not pointing to any of the node, then it will print it as minus 1. So, so for that case, you can see here how it is going to print it as minus 1. So you can see here, if ptr of next is not equal to null, then it will print the data. If it was null, then it will print it as minus 1. So that's it. Okay, let me minimize and let me submit and see. This case is processing. Yes, we got the right output. Okay. So this is how the program is running. So if you know in-order traversal, then it is an easy problem to solve. If you don't know in-order traversal, try to learn it, and after that you can come and solve this problem. So it will be easy for you to analyze how these processes are working on. Okay. Okay, let me see you in the next video. Bye.